Well, welcome back. It's a gorgeous morning up here in Park City, and I'm excited for this next segment and honored to help host this one. We have with us Ben Smarr, and many of you know Ben. He's not a stranger to FiRe, nor his family. And he's a National Institutes of Health Postdoctoral Fellow at University of California, Berkeley. And so we're excited to have Ben with us today. The next half hour we're kind of covering as a three-act play, if you will. We have two topics, as you can see up above, and we'll hit each of those. And then the third act is up to you. We invite you for some Q&A here as we pick Ben's brain on some exciting research and things he's doing. So the first one, Ben, is that computer modeling synchronicity of whole body systems. And so tell us a little bit about that. What are you doing there?
What does that mean? Well, we just had a great introduction by Dr. Kurisu about how the body is a unit. And that's really true, but it's very difficult to study. So there isn't a very mature science of understanding how to take advantage of the fact that your body is a body and not a collection of disinterested organs.
Right.
So that's a lot of what my work is now, is trying to understand scientifically when something in my stomach changes, how is that also going to affect my heart rate, right? Or if I'm getting some disease state, how is that going to also affect, and it's a disease in my kidneys, that's also going to affect my activity patterns throughout the day, or my body temperature regulation, or other hormonal systems. And the reason that that's really exciting is, when we have all of this omics, we generate huge amounts of data, and we can do amazing pattern recognition of, these genes plus this expression pattern of proteins, indicates this onset. But you can't do that minute to minute across your lifetime. It's too much data to manage. It's too expensive to generate. And so we can take advantage of the fact that a lot of these systems are coupled to each other to pick a few that are really good reporters moment to moment, like body temperature I'll talk a lot about today. But it could be heart rate or heart rate variability, skin conductance, any number of things. And those are continuously changing in patterned ways. And so if we can sort of listen to that signal, then we can intuit a lot about what must have been happening to all of those omics. And then when there's a perturbation in the signal, then we can go in and say, now let's look deeper and really figure out the system.
Now, some of your research, Ben, has involved mice, of course, as research does, and you brought a little something to share here on the screen.
So can we throw the slide up there? I swear I just have the one slide.
We're using this clicker, but it's not working.
So I tell people, well, I look at body temperature across time, and all of these diagnoses just leap out at you, and people go, what does that mean? It's hard to picture. So I thought I would just show a picture. So what we're looking at here, this is from mice, and this is every minute across a day, and then the days are stacked on top of each other. So you're looking at a month worth of body temperature activity. The deep blue, if we start, up in the corner.
Excuse me, are you going midnight to midnight, or?
In this case, we're going something like that. They're active in the night, so where it gets bright white, that's where they wake up and they start running around in the morning. And then when it goes back to the deeper blue, that's when they've gone to sleep. And if you guys will, I think you can all notice with me, if we look sort of 9 rows down, right, so a little more than a week into this, all of a sudden it totally changes. The activity, that big white spike becomes much less prominent. The whole thing looks kind of more purple, right? That's the onset of pregnancy. Now, the state of the art when you're doing animal research is that when they give pups, that confirmed that they were pregnant, right? So it's a pretty low bar of progress, and it's not because we don't do millions and millions and millions of studies, right, and learn lots of very valuable things about development that way, but it's just hard to see, and it's not standard practice yet to assume that we have miniaturized sensors, miniaturized antenna, that we can take both higher frequency measurements and for a longer time because of the technology evolving.
Right.
But when we see the data, I don't have to be that good a biologist to look at this and go, wow, that really changed, right? We can detect pregnancy with 100% accuracy now, right? Within a few hours of when they've mated. And then just to finish up, when it gets red, that's birth. Now we can detect birth with more traditional means, of course, but but you can also then, doing more mathematics, which is where my career has now pivoted to data science from biological sciences, because it's the computation of finding patterns that lets us do more subtle things. So within these same data, there are frequencies that overlap that compose this overarching daily rhythm. Those frequencies change in a way that lets me predict from within the first day of pregnancy whether that pregnancy will be healthy or whether it's going to end up having complications. And I can do that with 95% accuracy from within the first day.
Wow.
So I've been finding more and more examples like that when I've been working now in animals but trying to transition to humans, because I'm really interested just naturalistically in the patterns, but of course if it can help people, that's much more exciting also. And so looking at surgery recoveries, looking at reproductive fertility and ovulation, looking at healthy aging, even looking at educational outcomes, you can find patterns that are very useful and predictive, but it's just not the traditional way of doing biology. So we have to bring in technology, we have to bring in engineers, mathematicians, computer scientists, and it's a wonderful, it takes a village kind of science now.
It seems like so often when you go to the doctor, you're looking at a point in time as a person, and you're not looking at the overarching trend for you. How with the rise of more portability of personalized health data, how does that affect these patterns you're looking at?
Great question.
Help me understand that a little more.
This is a great question, and I've started now reaching out to a lot of wearable device companies and medical companies that are interested in this, because we really don't know any of it. It's all early days. It's a bold new world here. And so what we can see is that the more cases that we get for that, so I've done a lot of work with sleep, for example, the more just very basic, useful discoveries about how sleep works we're able to pull out of all kinds of wearable things. And we don't know yet what's the best channel. So we were just hearing somebody talk about one of the reasons we do this massive omics is so that you can pare down to the few things that turn out to be interesting for that individual, and then you can focus on them. And we are still figuring out, temperature in my hand is not the same as on my wrist or in my armpit. Where are these signals the most informative and for what conditions?
So which body systems are the most important to track over time, would you say?
I'm a big fan of heart rate and what I call axial temperature. So I actually go around with sensors taped into my armpits.
Who doesn't, right?
Like you do. Yeah. And that generates a lot of the data that helps me generate hypotheses. So I can watch myself get sick and see that my sleep rhythms were disturbed, and I go, ooh, I wonder if that's a thing. Now we can study that, right? Whereas otherwise, I would never know. And that's one of the things that's so transformative about this. It's exactly what you say. If I go to the doctor, and I'm a mouse, and I have one of those pixels, I don't know anything. I know that I'm roughly in the range where life should be, right?
Right.
If it's a context, then all of a sudden I can get way ahead of changes. I can see them coming. And because the wearable devices are becoming so small, and in fact I think we're going to move past wearables to ambient sensors at some point. But it's small, it's not invasive, it's relatively cheap compared to going to the hospital for something, and the data that it generates is much easier to manage as just sort of a time series of data. So you can make medicine faster, cheaper, more personal, all at the same time. And I mean, that's awesome, right? And that means we also need to reach out as scientists and collaborate with clinicians and figure out how do we squish that data now into something that's useful instead of a giant hairball of graphs that none of us really know how to read, right?
We've seen this with NASA for a while, right? The astronauts go up there and they have the different sensors on them all over.
Yeah.
So where is this going? Do you think we'll have implanted sensors, or how do we track that ongoing data so we can look for these patterns?
I think that's a great question, and I'm really interested to find out. I think ultimately what we're going to do is we're going to be in a situation where, I walk into the room here, the room knows that it's me, can recognize me by my various vital signatures, by the fact that it's my phone will help sometimes, whatever that would be. And I won't really have to think about it, right? I think this doesn't work if I have to worry about plugging the thing in, changing the battery, putting it on in the right place. It really is, that's a gateway. And so that's letting us now, for the first time, see that there are these patterns. The more people understand the potential of mining these patterns for useful information, the more that's going to drive the market to say, okay, but how do we do this in a way that people want to do it, right? So I think we're just going to end up, if things go well, we're going to end up in a very smart world, and that world is then going to, with artificial intelligences, for example, that we were hearing about earlier, help us live better lives.
Sure, and the warning signs, it'll be way earlier than they are today. Well, this will seem like the dark ages when you weren't tracking those things all the time?
Exactly.
Before?
How could you live without data, right?
Right.
And this will affect education as well, because some of the work that I do is with my students, because we sort of are our own guinea pigs initially. And you see actually very striking predictors of how well they'll do in their classes based on, for example, how stable are the rhythms in their sleep or their circadian rhythms, which, thanks to the Nobel Prize recently, now I think a lot of people know what that means.
Well, you talk about education and research. That's a good segue into the next act of our play.
Sure.
So if I can click back to the initial slide there. had the questions up there. But the next one is kind of, who are scientists' customers?
Right.
Is the question, and how reshaping publicly funded research could lend to rapid evolution in personal productive medicine. So we were talking just yesterday how a lot of industries really are struggling to find out who their customers are.
Right.
And tell me kind of your epiphany there with scientists and how
Right. Well,
they don't really know their customers as well as you'd think.
I had a moment of clarity because I was at a furniture sales conference because as a biologist, obviously. So I was working with a sleep company that wants to help figure out how to make smart mattresses as part of this ambient sensor world. So they had brought me to this thing. And there were all these furniture salesmen saying, you know, what's the showy thing I can do to get someone to come into my shop so they don't just shop online? Mm-hmm. And then they had these CEOs from the online furniture sales that were doing really well. And they said, well, it's not about tricking your customers. Figure out what your customers want and give it to them. Mm-hmm. And then they'll be very happy to be your customers. And so I said, wow, who are my customers? I thought maybe this wouldn't relate, but it's actually pretty profound. I'm a public scientist. I do this stuff because I think it brings good into the world. And I only produce things for other scientists. My career is guarded by other scientists saying, yes, you've published enough papers. Yes, you've written your grant in the way we want to understand the grant. Yes, you're going to get a promotion.
But who is that end customer, right?
And those scientists look at a very technical language, and they have a very different mental framework than the people that I actually want to work with. Right. And so it has distracted me for a lot of my career. I would say all of my early career. I've been treating other scientists as my customers, and that's not really what I want to do. I want the public to be my customers, right? I want to be a scientist engaged with people so that we can learn how people are, because we still know very little.
So you're saying it's more important to help people than it is to wow fellow scientists. Is that kind of what you're...
Well, wowing fellow scientists is an important filter in so much as I want to know that what I'm doing really stacks up. It's really rigorous science. That's still very important to me. But that can't be the end of the game.
Right.
And if I'm taking time away from my science to learn how to communicate with the public, traditionally I'm punished for that, right? Because how come you weren't spending that time making papers?
Yeah.
And so I think we need a culture change within science.
So how do we do that? How do we break out of that publish or perish mentality that's kind of plagued researchers for decades, really?
Well, that's a real challenge, and I'm learning that as we go. But I think it's another one of these nice it takes a village moments. So the more I'm doing collaborative science, you know, learning the mathematics and the sensor engineering, but I'm never going to be a top-level engineer. There's people that do that brilliantly that I get to work with.
Right.
The more we can collaborate, the more each project is a little bit less work for each of us. And that means we get to also scale. And rather than only scaling the research, if I'm publishing, you know, tens of papers instead of dozens of papers or hundreds of papers, I'm pretty happy, really. Mm-hmm. That's enough to prove, yeah, okay, I'm a productive scientist, I get to play the game in a traditional way. But it also then means I have perspective to things that people really care about, like our health is generally something we care about, our education, aging well.
Sure.
And I have the time to then say, let me take some of that time and invest it in making sure the public wants this to grow, right? And I want the public to be as excited about this as I am because it's exciting, because it's a basic human thing. But my funding comes from the public. So if they don't understand that that's exciting, I've failed them.
You failed your customer.
I've failed them for them to see where that investment went.
Right.
So I think it's on us as scientists to open that culture a little bit. I think that's going to take brave scientists not sort of short-term punishing each other for doing other things. It's going to take an evolution in the culture of how do you share a product like public engagement. And then it's going to take a shared effort from the public, right? So it's going to take legislators who say, you know what, I like talking to scientists. That's cool. It's going to take the public saying, we want a scientist to come here and talk to us. That's really informative. That's exciting. The more we can have those positive conversations, I think the more we can get society back to scientists really dealing with their customers correctly, which is with all of society.
Yeah, and I appreciate that. I'm a government guy, a legislator. In fact, welcome to Utah officially, everyone. We're thrilled to have you here. But let's see what we always have a great audience here
Absolutely.
at FiRe. Let's see what questions they may have for you on either of these topics or fair game. So as usual, we have the two microphones there. Mm-hmm. What questions we have for Ben Smarr today on these topics?
Oh, yeah, go ahead.
A couple people coming forward.
I'll go first. Benjamin, thank you. You're a embarked on a really courageous experiment here in terms of the social piece you've picked on. I'm curious about how you see us moving this mentality into the educational sphere so that scientists aren't seen as the other,
Right.
but seen as with us. I think when I look at science curriculum, I always have this feeling that it's defined in terms of becoming the other. Scientist is somehow
Yeah.
different, and I want to demystify that. So tell me what your thoughts are on that.
That's great. That's spot on. Thank you. I think we tend to hear a lot about the same problem within a medical sphere, right? How do we engage patients more? How do we get doctors to spend more time actually listening to the people they're dealing with? And I think it's the same in education and in science. I think given that we don't know very much about how basic human physiology works, I gain a lot by being able to find people who want to know more about the science. And I get in the way of that if I have to wear my lab coat and use long Latin names for things, right? So part of it is education to help education in the sense of educating scientists to learn how to talk like they did before they became scientists. Part of it is, again, not discouraging other scientists when, as I did through grad school, I've done hundreds of hours of community outreach and largely in K through 12. And it's exciting for me. The schools love having a real scientist come in, tell them about, what's a brain, how does that work? And it's really good for me because I have to practice. If I can tell a third grader what the brain is and how synapses work, I must be speaking pretty clearly, right? And if I can't, then I get that feedback real fast, and that helps me, right? And that's helped my grant writing, that's helped my paper writing. So, I mean, it does help within science. But what I would love to do is people that have, undiagnosed medical problems like we were just hearing about, which, by the way, is all of us, right? I mean, all of us are going to die from something, and most of us are not really going to know what that was, right? And late term, maybe it'll start to manifest as a cancer even, and then we'll say, oh, well, I know what that is. Something caused that cancer, right? All of us have undiagnosed deviance from optimality. And so the more that people can come and say, hey, you know what? I'd like some science on me, please. Let me give you some data. Let me figure out what that data taking would look like. Is it temperature in my armpit? Is it my Fitbit? Is it social media? And let's figure this out, right? There's plenty of scientists that want interesting problems. I think there's a real synergy there. And again, I think that then comes from the culture. And in fact, I think it raises an interesting point, which is, if you don't mind me carrying on a little bit.
No, I mean,
One
we
of
want
the-
to hit the others, but we got time.
Absolutely. I think one of the major changes that other people can contribute, right? So I can do my part as a scientist trying to be more open. One of the things other people can contribute, though, is trying to encourage a world where it doesn't require bravery to want to share your data, right? And anything that makes people scared about sharing their data, and of course there's lots of security concerns, and is my insurance going to say I have a pre-existing condition, and whatever it is, those are real issues. But whatever we can do as a society to overcome them, that's going to let people share data, and then we can do science on people, and then we can, as Lee Hood says, move past disease, because we'll be able to catch all these things early. We'll be able to learn the patterns. And if we don't share the data, we won't be able to do that. And so there really is a social imperative on finding a way to be positive and open, scientists working with legislators,
Right.
with the public making clear what they want, so that we can live in that better world.
Yeah, good. Let's take some questions from this side of the room.
So, my name is Monica Harrington, and I work a lot on reproductive health issues.
Great.
And I wanted to encourage the work that you've been doing in understanding prenatal stresses and the impact that that has. One of the things that I'm really interested in is making pregnancy more of an intentional decision,
That sounds like a good idea.
because of all of the positive impacts. We know about some of these outcomes, but I think it would be really helpful to flesh out the story of how some of those early prenatal stressors impact the well-being of children later on.
Absolutely.
And so I'd encourage you to do more work in that area, and we should talk.
We should talk. Well, and in fact, I just published a paper in Scientific Reports looking at how if you can do this kind of minute-by-minute tracking, you can quantify the amount of circadian disruption that, in that case, it was, once again, mice. In fact, it was the same mice. That's how I stumbled into this. We were able to track their pregnancies, and we could then see if they were getting circadian disruption. When the pups were born, they were born a little underweight, and when they grew up, they became socially avoidant and did a lot of sort of repetitive fidgety things. And, you know, it's not the same as autism, and it's a mouse, but it's a lot of very similar kind of traits, autism or ADHD or something like that. And that was the first science showing that it's not just physical pollutants that we have to worry about in development, but that the time really matters, right? That the timing of a healthy, normal circadian rhythm as you're pregnant shapes how the brain chooses to lay down neurons and which things are growing when. And if that's weird because you're on shift work or jet lagged, then you're messing with that process. Mm-hmm. And that's not meant to be a scary thing. I think one of the things that comes out of more data is that it's liberating, right? We can celebrate our heterogeneity. We can say, you know, teenagers aren't lazy. Their circadian clocks are delayed by sex hormones coming up. And look at all these people where we can measure that. And it's not the same for everyone. But here's the extreme late types. They really suffer when they're in schools that are made for early people, which schools are currently. But if we can identify that, we can just let them take classes later, right? We can encourage online classes to develop that cater to us in a personal way, just like we like everything these days being personalized, right? So the data lets us match that in a much higher fidelity than we're able to do currently. So I think that's really hopeful. We can say, well, gee, if you're getting pregnant, let's make sure we're taking you off the rotating shift. Like, let's be conscious of that and take advantage of it, rather than just sort of adding it to the uncontrollable list of things that are scary, right? Mm-hmm. But again, that's going to take society. I can tell you the science, but I can't change school schedules or make employers, you know, want to give good time to pregnant women, so or whatever else it would be. So that's again where this public engagement really speeds the whole thing, and I want to do my part. I think, honestly, the artificial intelligences are going to mine this data a lot faster than I and my colleagues ever could, and we're going to end up with way more of these patterns than we're ready for. And so that, again, becomes a real social engagement issue. How do people change the way we do things to encourage and accommodate that so that we're all able to live more personalized, happy lives? I mean, that sounds like a good thing, right?
Right. We can probably fit two more questions in.
Can I just follow? I wanted to follow up on the reproductive
okay.
health one. I'm at UC San Francisco at the Institute for Health and Aging, and there's
Great.
also a preterm birth initiative
Yes,
there.
yes.
And looking at preterm birth among low-income women, women of color, primarily African-American women, and also there's the issue of maternal death post-delivery. Right. And I'm wondering, because of the stress that low-income women in particular have to deal with, and racism of African-American women and so on, I'm wondering if this is something that could connect with that initiative.
Already happened.
Yeah, yeah.
So the Preterm Birth Initiative at UCSF is a tremendous group of people, and they have a cohort of patients that are out of Oakland, as well as different areas around the world and Africa, trying to understand why, even with education or socioeconomic factors controlled for, minority women have much higher rates of preterm birth, and that's very bad because the earlier the kid comes out, mm-hmm. the higher the mortality, the higher the chance for all kinds of disease. Sure. So, like, what's going on? And there is a major disconnect between the kind of work that I do, which is this very data-intensive, future-looking stuff, and the realities in the clinic, where the doctors say, of course I want to help, but I don't even have time to read the charts. You know, so how am I ever going to figure this out? And, you know, these poor women come in and give testimonials about, I have to see 4 different specialists. They won't schedule together because they all have their own thing, so I have to take 4 different days off of work to take a bus down to where the hospital is, and incredible stress, right? And meanwhile, I have to work 3 jobs because I have to be able to pay for all of that, and so I'm not getting sleep, and now my sleep is disrupted, and that's a risk factor, right? And I mean, it's a very, very complicated problem that I, as a scientist, am not about to be able to solve. So what I want to do is use the science to arm the doctors, to arm the patients, to arm the people making decisions about how do we refund this, how do we encourage this, because if those conversations don't happen, then we're going to have a harder time moving forward, right? But it's going to take everybody being engaged.
Right. Let's come over here.
Yeah, first of all, I'm happy with a very dumb mattress, so I don't really want
You
feedback.
think that.
Yeah.
You don't know the alternative.
I like data, and I was in Lee Hood's first 108 people,
Awesome.
and that was, I got some interesting stuff. And I take my blood sugar on a regular basis, even though I'm not diabetic or pre-diabetic, because I think it's interesting and I like to watch it. But I'm wondering, with all these devices, I have a concern that we start to see the body as much more separated than we already do. We already see, a separation between it's us and our body, right? So we start to see it as a thing, and if we start, and as opposed to using those information sources as feedback
Great.
to help us learn, if I feel this way, what's going on? So the next time I feel this way, you know what I mean? So
Absolutely. No, and I think it's a great
If you could
point.
speak to that.
Absolutely, thank you. I think it's a great point. Using the data as feedback. So rather than me owning the data, right, or your device company owning the data, what I think would be really cool is if you just got your data real time all the time, right? And then that's how you can learn these patterns. So if one of the studies that we've been doing in San Diego is with a group looking at gastric activity, so electrical signals in your intestines and stomach, and it goes in these waves, so you can read it as a pattern. And you can actually, it looks like, it's early days, you can not only tell somebody's eaten, you can tell somebody's gonna go get lunch, right? You can see their stomach sort of drive their behavior as the activity comes up, and then at some point it peaks and they go, I've worked long enough, I'm gonna go get a sandwich. And you can see it coming, right? So clearly you could use that as training, and you could say, I'm starting to learn when, am I nervously snacking, where's that coming from? Or my blood sugar is changing, and I'm sort of developing an intuition because I see the data. I use it as a training set to say, well, how am I feeling when I see it start to go up, and I can be more aware of it. And that kind of mindfulness, I think, is a way more positive way to look at it. I mean, your body is an object at one level. It exists in physical reality, and we can measure it down to the atom, but it's also yours, right? And same with your brain. So the more aware of it you are, the more conscious we can be, the more we ought to be able to get out of it, is my hope.
Yeah. Let's slip in one final question before we wrap up.
You sure we have time?
Yep.
Okay, well, switching to the other half of what you were saying, the collaborative aspect, you say that people are deterred from collaborating with each other because of allocation of credit. They don't want to lose the credit for the things, their data or their conclusions. Of course, back in the 70s and 80s, some of us old farts, when we were your age, were worrying about the silo effect.
Right.
Over specialization.
Right.
And the good news, the glass half full in this century, is that there's a lot less of this than we thought there would be. There's web searches and collaborations,
Yeah.
and this conference is an example, collaborations across boundaries. So what else could facilitate that? And I'm thinking micropayments and microcredit. If you share a portion of a data set and it's later used to draw a conclusion, your brother might be able to come up with a method to track
Right.
where the data came from, so that some microcredit can come in. And I've been working on micropayments, if anybody's interested in that.
Well, and Werner
That's
Vinci gives a great vision of this in Rainbow's End, which, if you haven't read, it's a very enjoyable sort of near-term future vision. Some of it is just generational, right? So that is to say, when someone reads my CV, they are not reading a AI agglomerated microcredit analysis. They're reading a piece of paper with my publications on it. So we have to change the expectation. How are we evaluating each other? And that the evaluators are part of that change. So that's going to take a little bit of just culture change within science. But you're right, conferences like this are amazing because you get smart people in different fields saying, gee, I never would have known that was possible. Let's figure that out, right? And then I love this because I hear all this engineering. I hear all of these people doing undiagnosed movies. That's really exciting to me because that's going to change how I'm doing my science. So I think the more we can encourage that sort of thing and make it visible as something that's valued, the faster we can move it. So, anyone who knows an old professor who says, in my day, we only use papers, have an intervention.
Yeah. Well, thank you, everyone, and what a treasure to have at FiRe here, all the way from UC Berkeley, Benjamin Smarr. So thank you.
Thank you. It's a real pleasure.
Okay. Thank you very much. That's great.